Welcome to Kanerika's podcast, The Digital Shift.
Thank you. It is really great to be here today.
Have you ever wondered why a highly anticipated software release suddenly slips into the red because, the quality assurance queue just could not clear in time?
Oh, yeah, that is a classic nightmare for so many teams.
Right. Or even worse, why a catastrophic bug only reveals itself right in the middle of a critical renewal quarter. I mean, that sends your entire engineering team into a weekend of just frantic firefighting.
Which is exactly what nobody wants to be doing on a Saturday.
Exactly. And if you are an engineering lead listening to this right now, you have probably stared at a Jira backlog and felt this exact friction.
Oh, absolutely. I mean, they feel it every single day.
Yeah, because across the technology landscape, engineering teams have drastically accelerated how fast they build. We are looking at, much shorter development sprints, far more frequent deployments, and this massive influx of AI-assisted coding tools.
Right, which are pushing code output higher than we have ever seen before.
But the thing is, testing capacity simply has not kept up with that sheer velocity of production.
It really hasn't. The math just no longer works, honestly.
Yeah.
When you accelerate the assembly line, but leave the inspection checkpoint at the very end completely untouched, the bottleneck is just inevitable.
Makes sense. You are just piling up cars at the end of the line.
Precisely. So our mission today is to rethink quality from the ground up. We are looking at, transforming testing from a final frantic hurdle into a foundational property of how teams engineer products.
Because speed doesn't mean anything if the product is broken.
Exactly. A faster release cadence does not automatically buy you better quality. If your testing infrastructure relies on legacy methodologies, all that development speed is quite literally just accelerating your path to a production failure.
Well, to really solve this speed versus quality dilemma, we kind of have to tear down the traditional definition of testing, don't we?
We do. We have to completely deconstruct it.
Because for the longest time, the industry has relied on traditional quality assurance, which operates almost entirely as a rear-view mirror.
Yeah, that is a great way to put it. It is historically a final stage defect checking process. I mean, think about the physical mechanics of it.
Okay, walk me through that.
Well, a testing team receives a compiled build near the very end of a software development lifecycle. They take that finished build and they basically check it against a static list of business requirements.
So they are just checking boxes after the fact.
Right. They are essentially hunting for defects in a completed product, completely isolated from the actual architectural decisions that created those defects months prior.
Wow. So it's way too late in the game.
Exactly. And by the time they discover a flaw in the logic, the cost and time required to unravel the code and fix it have just multiplied exponentially.
I used to think of traditional QA like a bouncer at the end of a nightclub line.
Oh, I like that analogy.
Yeah, you wait all night, you finally get to the door, and the bouncer just rejects you because you don't meet the dress code.
Right. It is abrupt, it is late in the process, and it sends you all the way back home.
Exactly. But let's take that a step further, because product engineering testing, which is what we need to move toward, is more like a VIP concierge.
A concierge, right, because they handle things proactively.
Yes, the concierge does not wait at the door. They call you a week in advance to confirm your preferences. They check the kitchen inventory before you arrive, and they walk you through the entire night.
They are engineering the experience to ensure failure never happens in the first place. That is the key difference.
Right. It feels fundamentally different from just checking IDs at the door.
It is. That concierge approach fundamentally alters the risk profile of a product. It shifts the objective from merely counting defects to active lifecycle risk control.
Which means it happens everywhere, not just at the end.
Exactly. Product engineering testing embeds itself into planning, architecture, build, release, and production. I mean, consider the whiteboard phase.
Okay, the very beginning of the project.
Right. When testing is involved in early architectural design, testers can actually evaluate API contract risks before a single line of code is even written.
Well, let's clarify what that actually looks like for the listener, just to make it concrete. An API contract is essentially an agreement on how two systems will communicate.
Yes, exactly. It dictates the format of the data being passed back and forth.
Right. So if the front-end team assumes they are receiving a user's date of birth in a month, day, year format, but the back-end team designs the database to send it as day, month, year, the system will just break.
It will completely break.
Yeah.
And catching that on a whiteboard saves weeks of recoding.
Catching it early versus catching it in production is basically night and day.
Precisely the point. Catching that in production is a disaster, but catching it on a whiteboard takes literally 30 seconds. And, the breadth of disciplines required to pull this off today is just staggering.
It's not just basic click testing anymore.
No, not at all. Functional testing, like clicking around a user interface to see if a button works,
Hmm.
is just the absolute baseline now. The modern testing landscape requires really deep, specialized engineering.
Performance testing is a great example of this evolution, actually.
Oh, absolutely.
I mean, it's no longer just running a massive load script the night before launch to see if the servers crash,
Right. It is so much more granular now. Performance targets now heavily align with Google's core web vitals, for example.
which impacts a lot more than just server load.
It does. We are measuring largest contentful paint, which is basically how fast the main content loads, and cumulative layout shift, which measures visual stability.
Okay, so visual stability. Give me an example of what happens if that fails.
Well, imagine a user goes to click a buy button on their phone, and a late loading image suddenly pushes that button down the screen so they accidentally click cancel instead.
Oh man, that is so frustrating when that happens.
Exactly. That is a layout shift failure. It directly impacts user experience, search engine rankings, and ultimately your revenue.
Right. And then you have security testing on top of all of that.
Yes, which has moved far, far beyond simple automated port scans. It really must map against stringent frameworks now. Things like the OWASP testing guide and the National Institute of Standards and Technology's Secure Software Development Framework.
And those frameworks demand baseline practices for continuous vulnerability reduction, right?
Yes, continuous is the operative word there.
Because they require teams to prove they're mitigating risk at every single stage rather than, just auditing security right before deployment.
Exactly. But I know this brings up a massive operational friction point for a lot of teams.
Yeah, I mean, if we are demanding that testing happens during the whiteboard phase, during the coding phase, and against these massive security frameworks, how do you implement that without grinding developers to an absolute halt?
That is the million-dollar question.
Yeah.
And it is usually where we hear the term shift left thrown around constantly.
Right. And I actually have to push back on this a bit, just to play devil's advocate. Doesn't shifting left just mean dumping a mountain of testing work onto the plates of developers who are already stretched incredibly thin?
I completely see why engineering teams panic when they hear the term, but that is a really dangerous misconception.
Okay, so what does it actually mean then?
Shifting left is not about making developers do all the manual quality assurance. It is really about moving the discovery of defects earlier in the timeline.
Finding the problems before they become massive issues?
Exactly. It means testing the actual business requirements before you even test the software. It means reviewing acceptance criteria and conducting threat modeling alongside the developers.
So it is more of a planning and alignment thing early on?
Right. The core philosophy here is economic, fundamentally. A defect caught during the design phase costs practically nothing to fix.
What if it slips through?
If that same defect is caught in a live production environment, it could cost millions in lost revenue, compliance fines, and, reputational damage.
Wow. So it is really about shifting the quality mindset left. But physically, to survive that amount of testing without slowing down, you have to rely heavily on automation, right?
You absolutely have to. You cannot manually test continuously at that scale.
Which I guess is the core driver behind QAOps.
Exactly. QAOps is the practice of embedding quality processes, automation, and environments directly into the continuous integration and continuous delivery pipeline.
The CI/CD pipeline, right? Let's break down the mechanics of that for a second. When a developer writes a piece of code and hits commit, what actually happens in a true QAOps environment?
Well, in a mature QAOps setup, that commit automatically triggers the CI/CD pipeline to spin up a fresh virtual environment.
Okay, so a clean slate every time.
Right. It deploys the new code, runs a highly targeted suite of automated tests, checking security, performance, and functionality, and then it pairs the environment back down, all within a matter of minutes.
That is incredibly fast.
It is. But this requires highly strategic execution. You must structurally distinguish between strict quality gates and mere informational checks.
Because if every tiny error halts the pipeline, the developers will just revolt.
Oh, they will absolutely riot. A strict quality gate is something like a critical security vulnerability or that contract-breaking API change we discussed earlier.
Something that actually breaks the system.
Exactly. If the pipeline detects that, the build absolutely must halt. The code cannot proceed. But a minor visual quirk, like, a menu button being 2 pixels out of alignment.
Right, that shouldn't stop a whole release.
Exactly. That should merely flag an informational warning to the team, not block a vital release. Confusing the two is the absolute fastest way to make an engineering team view testing as an enemy rather than a safety net.
That makes total sense. And, when we at Kanerika implement these automated QAOps-driven pipelines for our clients, the results genuinely change the business trajectory.
Oh, I bet. The metrics on that must be fascinating.
They really are. By treating testing as a built-in function of product engineering, we see massive operational shifts. For instance, we recently worked on a highly complex connected vehicle telemetry platform.
That sounds like a heavy data environment.
Oh, very heavy. But by implementing strict CI/CD integrations and automated testing strategies, we actually cut the total testing time by 74%.
74%. That is a massive reduction.
Yeah, it was huge. We also reduced infrastructure-related issues by 45% and simultaneously lifted overall platform scalability by 30%.
Which is exactly the goal of this entire methodology.
Exactly. You go from hoping the software works at the end of the month to knowing it works every single time a developer commits code.
Right. And achieving that level of efficiency, cutting testing time by 74%, naturally leads organizations to seek out the next frontier of acceleration.
Always looking for the next speed boost.
Always. Having optimized their pipelines, enterprise teams are now looking to artificial intelligence to push those boundaries even further.
Of course. AI is everywhere right now.
It is. And the data on this is highly revealing. In 2026, 61% of organizations are already utilizing AI across the majority of their testing workflows.
Wow, 61%.
Yes. It is no longer experimental. It is truly the operational baseline now.
The adoption rate is massive, but when you look at what is actually holding teams back from fully utilizing AI in testing, it isn't the budget, which surprised me.
Right. Budget is rarely the top blocker for this specifically.
Yeah, 37% of engineering teams cite integrating AI with their existing workflows as their top challenge. It tells you that the operational friction of AI is the real hurdle here.
It is a huge hurdle. Integration is incredibly complex.
I like to frame it this way, actually. AI in testing is not a fully autonomous robot that you just plug in and walk away from.
No, definitely not.
It is more like hiring a highly creative, incredibly fast, but slightly forgetful intern.
That is a brilliant way to describe it.
Right, because they will find entirely new paths through your software that a strict automated script would never even think of, but you absolutely still have to double-check their math.
Yes. The probabilistic nature of AI makes that intern analogy incredibly accurate.
So where is this intern actually useful right now?
Well, where AI truly excels right now is in highly specific, practical use cases that eliminate manual toil. It is phenomenal at generating baseline test cases straight from business requirements.
Oh, that saves so much time.
It does. And we are also seeing incredible utility in self-healing automation.
Okay, wait, explain how self-healing actually functions, because to a lot of people that just sounds like pure magic.
I know it sounds like science fiction, but it is quite practical. In traditional automation, if a developer changes a login button's internal ID tag from login BTN to submit BTN, the automated test just fails because it cannot find the original tag.
So the test breaks and someone has to go in and fix it manually.
Exactly. An engineer has to manually update the script. But self-healing AI analyzes the document object model, which is the underlying structure of the web page.
Okay.
It sees the ID changed, but it recognizes that the button is in the exact same location, has the same color, and performs the exact same function.
Oh, wow.
So the AI automatically updates the test script to look for submit BTN instead and just keeps running, entirely preventing a false alarm.
That saves countless hours of maintaining those flaky tests.
It really does. Furthermore, AI-driven risk-based test selection is slashing regression times.
How does that work?
Well, instead of running a 10-hour suite of 10,000 tests every single time a small change is made, the AI analyzes the specific branches of code that were altered.
So it knows exactly what was touched.
Yes. It maps those changes to the exact tests that touch that code, and perhaps only runs the relevant 500 tests instead of all 10,000.
Which means you get the same level of confidence in 20 minutes instead of 10 hours.
Exactly. It's a game changer for delivery speed.
But, the danger of the forgetful intern still remains, right? If you just blindly trust the machine, you are introducing a massive new risk vector.
Oh, absolutely. Testing an AI-enabled product or using AI to test software is an entirely different scientific discipline from conventional automation.
Because it's guessing, essentially.
Right. AI outputs are inherently probabilistic.
Yeah.
They guess the most likely correct answer based on patterns. If you are utilizing silent self-healing automation, you have to be exceptionally careful.
Because it might fix something it shouldn't.
Exactly. An AI might silently fix a broken workflow in the test environment, which looks great on an executive dashboard, right?
Green lights across the board.
Yes, all green lights. But it could actually be hiding a critical defect that will still break in production for the actual end user.
Right, because the AI doesn't actually understand the business context of what it's testing.
Exactly. Generated tests always require a human oracle, basically a domain expert who can verify that the AI's logic actually aligns with the business goals.
So humans are still very much in the loop.
You simply cannot automate away human judgment. The AI might write a brilliant test to verify a user can add items to a shopping cart, but completely forget to assert whether the final total price is calculated correctly.
Which is obviously a catastrophic failure for an e-commerce site.
Exactly. So you need that human oversight.
Okay, so we have established that AI isn't a magical silver bullet, and that modern testing requires a vast array of specialized skills. I mean, from core web vitals to OAuth security frameworks to managing these complex CI/CD pipelines.
It is a massive undertaking for any team.
Which begs the ultimate operational question. How do enterprise teams actually staff and pay for this level of capability without their engineering budgets spiraling completely out of control?
Well, it really begins with avoiding the trap of hourly rates.
The race to the bottom.
Exactly. When organizations compare testing vendors purely on who provides the cheapest hourly rate on a spreadsheet, they are setting themselves up for financial failure.
Because the cheapest on paper is rarely the cheapest in reality.
Yes, exactly. The cheapest paper proposal is consistently the most expensive in practice. A low hourly rate usually masks a junior-heavy team that requires constant hand-holding, incomplete test coverage, or just a complete lack of long-term automation strategy.
And it completely ignores the hidden costs that eventually blow up the budget. I mean, test data creation is a massive one.
Test data creation is a perfect example of this.
Yep.
You cannot test modern software using real customer data because, privacy laws strictly prohibit it.
Right, GDPR and all of that.
Yes, exactly. So you have to generate synthetic data. Creating complex interconnected data sets that mimic real-world behavior but remain completely anonymous requires immense engineering effort.
Which a budget vendor might not know how to do.
Right. If a cheap vendor doesn't know how to automate synthetic data generation, you will pay for hundreds of hours of manual data entry. And you also have the ongoing, grueling maintenance of flaky automated tests. And of course, the ultimate hidden fee, the astronomical costs of defects that slip into production simply because the testing vendor didn't understand the underlying product architecture.
Wow, so you end up paying for it one way or another. When an organization finally recognizes they need a structured approach to this, what are the actual operating models they're looking at?
There are generally 5 structural options. First is QA staff augmentation, where external testers embed directly into your existing teams to boost capacity.
Okay, just adding more hands on deck.
Right. Second is project-based testing, which is scoped strictly to a specific one-time release or migration.
Makes sense for a big launch.
Exactly. Third is managed testing services, where a partner owns the entire testing process, the tooling, and the reporting. Fourth is QAOps as a service, which focuses strictly on implementing continuous testing right into your CI/CD pipelines.
Okay, building the infrastructure.
Yes. And finally, for massive enterprises, establishing an internal testing center of excellence to dictate standards across multiple disjointed teams.
I look at those 5 models, and honestly, outsourcing the whole thing to a managed service sounds like the easiest headache relief.
It is tempting for a lot of leaders.
Yeah, I mean, if testing is this complex, why shouldn't a company just hand the keys to a managed service vendor and wash their hands of it entirely?
Because washing your hands of quality is fundamentally washing your hands of your product's reputation.
That is a very stark way to put it.
It is the truth. In practice, the most effective setup is unequivocally the hybrid model.
How does that balance out?
Well, the internal engineering team must retain the deep product knowledge, the understanding of the business requirements, and most importantly, final release authority.
And the partner.
The partner organization provides the deep automation engineering, the specialized scale for things like load and security testing, and the advanced tooling that is just too expensive to build in-house.
Okay, so they bring the horsepower, but you steer the car.
That is exactly it. Handing over final release authority to an external vendor is a fatal mistake.
Because they don't share the business risk.
Exactly. Your internal organization must own the risk tolerance. The vendor can tell you there are 3 minor bugs remaining, But your internal team has to make the business decision on whether to launch anyway or hold the release.
That makes perfect sense. And we see the reality of that hybrid approach driving incredible outcomes every day.
I'm sure Kanerika has some great examples of this in action.
We do. At Kanerika, we approach this by really treating testing as a built-in pillar of product engineering. It is not an afterthought for us. It is woven into the very fabric of how we design and build software.
Which is exactly the shift we've been talking about.
Right. For example, we recently deployed an automated geolocation testing framework for a major construction management platform.
Oh, geolocation testing is notoriously tricky.
It is. So, to bridge the gap between their business requirements and the technical execution, we integrated tools like Serenity BDD and Cucumber.
Ah, Serenity BDD and Cucumber. The real value of frameworks like Cucumber is that they utilize behavior-driven development.
Right. They allow teams to write automated tests in plain English syntax, given when, then.
Yes, which makes it readable for everyone, not just engineers.
Exactly. A product manager can read the test and confirm it matches the business logic perfectly, and the pipeline can execute that same plain English as code.
It is a brilliant way to keep everyone aligned.
It really is. By integrating those tools, we actually cut their testing errors by 30% and reduce their time to market by 20%.
30% fewer errors is massive for a construction platform.
Yeah, the stakes are high there, but, the overarching metric is what truly matters to business leaders. Across our product engineering engagements, our clients see their delivery cycles move up to 65% faster.
65%.
Yes, and while doing that, their overall engineering costs drop by up to 40%.
That is the holy grail right there, speed and cost reduction.
Exactly. But that dual benefit of speed and cost reduction only happens when quality is engineered from day one, not, checked at the very end.
That synthesizes the entire paradigm shift perfectly, actually. Quality absolutely must be planned early and tested continuously. You cannot bolt it onto the side of a sprint on a Friday afternoon.
No, you definitely can't.
Because automation debt and thin regression coverage, they rarely announce themselves with warning bells. They show up silently.
They just creep in over time.
Yes. They manifest as slower and slower release cycles, widespread team burnout, and lead-stage firefighting that happens months after the initial architectural choices were made.
It really requires a profound shift in how we view the entire life cycle of software.
It does. It changes everything.
So, to bring this all together for you listening, I want to leave you with a final lingering thought. Look closely at your own development pipeline today. If your testing suite is generating hundreds of minor alerts every day that your engineering team routinely ignores just to push a release out the door on time, well, who is actually in charge of your product's quality today? Your engineers or your automation debt?
That is a question every technical leader needs to ask themselves.
Absolutely. Thank you for joining us on this deep dive into the future of product engineering. Until next time.